All right, good morning, everybody. Here we go. So chapter 19, practice quiz, start to finish. A 2015 poll found that 9.3% of teenagers had used tobacco products in the previous month. Current studies suggest it may be on the rise due to the popularity of vaping. In a recent random survey of 500 teenagers, 61 responded that they had used a tobacco product in the previous month. What do you conclude about the rise in tobacco use? So our null hypothesis, for the appropriate hypotheses, we write 2. H naught, H alternative. So remember how you write capital H with a little 0, capital H with a little uppercase A, and these little colons are setting up our hypotheses, okay? So we're going to start by saying, you know what? Let's make this not P observed because we didn't really observe this. This was information that was given to us. So P for this is going to be 9.3%, which I'm going to translate to 0.093. So we had a p-value of 0.093. We are testing to see if it is on the rise. So we're thinking, is it greater now than that 0.093? So your null hypothesis, your null hypothesis is always going to be either an equal to or greater than or equal to. It's always going to have some sort of equal sign in it. Always. Some sort of equal sign or greater than or equal to type sign. With your alternative, it's always just less than or greater than. There's never an equal sign part of the alternative hypothesis. So that's it. Okay. Check the necessary assumptions. The general assumptions are, were these teenagers randomly selected? We're assuming so. 500 teenagers is less than 10% of all teenagers, I'm sure. And then it says, usually the other assumption is you should have 10 successes, 10 failures. We have 61 that said they had the previous month. So we're assuming that we have enough responses for yes and no. Were they independent of each other? We're not quite sure. We're just assuming that they were. Okay, so we're going to say the necessary assumptions. Are they any of them not met? They appear to be all met. So the big key word here is assumptions. We're assuming this stuff. Okay, we don't know exactly if this is random or independent. We don't know. We're just making the assumption that it is because they didn't tell us enough detail or information about it. They didn't give us pages and pages of this is how we did our surveys. Here's how we selected our participants, okay? In an actual study, if it's a serious academic study, they will tell you all those things. Like if you're doing research, you need to be presenting all that data of how you did your research to make sure your information is valid, okay? But for the right now, we're just making a lot of assumptions. Perform the mechanics of the test. What's the p-value? So that's all this stuff over here, like the example test or the example from the book. Okay, so we already did a null hypothesis. It's also a greater than. So it says here we should have the n value. So our n is the sample size of 500 teenagers. And our p-value, we're going to do p naught, okay? Our p naught was 0.093. And our q naught is going to be 1 minus that number. Okay, because p and q always have to add up to 1. So if you can get your p-value and then take that away from 1, you should always get your q value. Okay, and I think I'm right, but let's just double check this. All right, perfect. Okay, so there's our p, there's our q. What else do they want? That's it. So then we could do our standard deviation, of what we're trying to observe. Okay. So I'm going to go ahead and do hat because we're trying to see our standard deviation of what we just observed, what we would expect from what we just observed. So they say do your p times q of your naught, p naught, q naught. So 0.093, multiply that by 0.907. Okay, so it's like 9%, about 90%, okay, with a little extra there to make that 100%. Divide that by your sample size, and then you square root that whole business. And that's going to be your standard deviation of what we're going to observe. Okay, so 0.093 times 0.907, divide that by 500, and then we radical the whole thing. And I get 0.01298885. I'll stop there. I'll go about 6 or 7 numbers out because remember, we want a lot of numbers here to help with our z-score. Okay, it might make a difference if we only round to 2 or 3 places. So we're just going to go 6, 7 places out. I would say at least 5, at least to your 100,000th place. All right, what's next on our example? So we're not done yet. We got to find our p hat. Okay, so what did we actually observe? So we're going to kind of use this number in a moment. Our p hat is what we observed, 61 out of 500. So what did we observe? 61 out of 500 is, okay. So if it used to be 9.3% used tobacco, in the survey they found 12.2% used tobacco in that survey, which once again is greater than what this is. But given the sample size of 500, if you did another sample of 500, maybe it would be like 40 or 50 or 30 or 70. We don't know, right? But another sample of 500 is probably going to give a slightly different result. So was this result 61 out of 500? Is that far enough from the average of 9.3, given the standard deviation of plus or minus 1%? You know, which it looks like I'm predicting right now we're going to have to say that it has increased. But let's find mathematically why we think that. Okay, so we found our p hat. Now we can find our z value. Let's go ahead and we'll just do the z value right here. So our z is going to be this p hat, which I don't think I wrote that out. I didn't write that out last time. So let's do this. So that's kind of what we're looking at here, is this number, take away that number, all divided by the standard deviation we found there. So p hat was 0.122, and there was no rounding to it. It was just that number, which is nice. Take away 0.093. And then, let me make that better. We're going to divide that whole thing by that standard deviation we found earlier. Once again, I wrote a ton of numbers out to make it as accurate as possible. And when I do that, what do I get? 0.122, take away 0.093, and hit equal. Divide that by 0.0129885. All right, and I get this value of 2.23274 something. With our z value, we really only need, I think, we can cut it off there. So I'm going to go ahead and call this 2.23. I'm going to cut it off there at the thousandths place. So I'm going to go ahead and make this whoops. I'm going to make that 2 a 3 there. So I'm going to round that one up. So for a z value, I'm going to get that right there. So am I done with the mechanics? No, it said go to a z table. So before we go to the z table, though, this is the greater than. So I always recommend just kind of like remind yourself, okay, that here's 0, 1, 2, and 3, -1, -2, -3. This is at 2.2, so it's cut off around here. It says greater than. So this right here would represent z being greater than 2.233. So I'm thinking right now, because it's greater than, I'm going to have to subtract my answer from 1. So I'm just going to kind of set it up and see my p-value is equal to 1 take away whatever I find on the z table. So z table, we can Google it. The z table PDF, look at the first one that comes up. You can go to your book. The back of the book, we have this stuff. So I'm looking at 2.233 or 2.23, I guess. So 2.23, 2.2, that's 2.20, so 2.20. 21, 22, 23. So 98, 71. We'll call it 98, 71. Because I think in the book it only has 4 digits. So our p-value, this is kind of like almost our final answer here. I'm going to say 1, take away 0.9871, 0.0129. Okay. Holy guacamole. A lot of work, right? It's not too bad, I think. So I have a very small p-value that's like a percent. That's like 1.2, 1.3%. Okay. So explain carefully what the p-value means in context. If the home team wins 50% of the time, the probability that p hat is 0.5329 would be 0.006. So that's some fancy stuff. So we're going to go ahead and say if 9.3% of, I'll put teens, use tobacco products, the probability, that. Now we're going to go back to what we observed here. Okay, this was 0.122. Probability that I'm going to go ahead. I think what I should have done there, I think, to make it more clear, was to turn that 0.5329 into a percentage. So I'm going to go ahead and change this up a little bit. Probability that 12.2% I'm going to make this a little bit cleaner. Probability 12.2% of 500 teens. I'm going to throw that sample size in there. 500 teens. Probability that 12.2% of 500 teens use tobacco is, now we're going to use our p-value, 0.0129. So here's kind of, change it up a little bit, and I apologize for that. I was trying to make it more clear. Hopefully you guys understand the context a little bit better. If 9.3% of teens use tobacco products, the probability that 12.2% of 500 teens use tobacco Yeah, I'm wording this all kind of weird. I'm sorry. Probability that basically right here, that probability that finding or selecting or in a random survey getting 12.2% of 500 teens that use tobacco is 0.0129. So I'm going to just randomly finding 12.2% of 500 teens use tobacco is 0.0129. So something along those lines, that's kind of how you want to kind of say it, is that based on the old information, based on this old information from 2015, if they used to observe this over 5 or 6 years with this rise in vaping products, since vaping is, still sort of like a newer thing for smoking, has it increased? Has it increased the use for teens? Okay, so out of 500 teens, 61 out of 500, which is about 12%, said that yes, they used some sort of tobacco product in the last month with a standard deviation of about plus or minus 1.2%. We found that the z-score is past 2 standard deviations from the mean, so it's kind of a small number. That translates to a p-value of 0.0129 from the z-table. And then we would say, based on this old information, if this happened, this is the probability that we would predict this to happen. So since it's such a small probability, that's kind of evidence that maybe things have changed. Like this doesn't happen very often. That's like 1 out of 100. It's not a really good chance of happening. So we're going to go ahead and claim that the null hypothesis is now we're going to reject that. And we're going to kind of say that we believe now that more teens smoke because of vaping or whatever reason. But we're just going to say based on some new data and research, it appears that more teens are smoking. So for conclusion, we reject the null hypothesis, the H0. Okay, why do we reject it? Because our p-value is so small. Our p-value is less than 5%. It's only like 1%. So that's it. That is your answer key. For your quiz, I haven't uploaded it yet. I'm still working on some different little small variations to make it a fun quiz. So that way it's not just silly. Yeah. Anyways, any questions, stick around. If you feel like it's nice and good and confident, you're like, yeah, I got this thing. Okay. Anyways, that's it for the video. I'll stop the video right now. And if you guys have questions, please stick around. Let's see. Stop recording.